Hey guys, in this video we are going to simplify the example on the screen there. Now, this could get a little confusing, but we can do this example in two of three ways. This, while more generally speaking, is often referred to as simplifying of a rational expression, can also be done using the long division method for division of polynomials. Synthetic division, on the other hand, would not be permitted. If I have a minute at the end of this, I will record myself doing long division on an example like this one. I know in my academic level algebra 2, I have not done division of polynomials with long division where your divisor, the thing we were dividing by, was more than a linear binomial. We're going to have a quadratic trinomial really when we set this up if we want to use long division. So I will model that. That would be a really great thing for you to check out. I'll thumbnail it at the end of the video. But for right now, an example like this, if you do see one on a test or an exam, you're probably looking to do factoring, restriction, and then simplify. So if we look at that numerator and that denominator, they're both factorable. The denominator may be faster to recognize as being factorable. It is the difference of two squares. The numerator, it should be clear that you should use grouping. And I know sometimes we talked about how grouping doesn't always work, but in this case, I promise it does work. So we'll go ahead and do this together right now. So we're going to factor this. Now I'm going to put the factored form in this next step over here, but what I'll do is I'll do the work for factoring on the side. So I have 3x cubed plus 5x squared minus 12x minus 20. If you are one of these people that really wants to switch these around, just please remember you don't have to. You never, ever, ever have to. Underline, greatest common factor. Here, my greatest common factor is x squared. Here, it's negative 4. If you only put 2, your two parentheses aren't going to match. So maybe if you're riding the struggle bus with getting your greatest common factors, finish this one because they only have x squared in common. I'm going to bring this x squared, I'm dividing by it out front because I'm also going to multiply by it. Inside, I reduce. I have 3x. I reduce, and I have plus 5. That means after I take something out of this, I should also be left with 3x plus 5. So you may ask yourself, 12 divided by what is 3, and kind of work from there if necessary. Okay. Now from here, let's do right there, this and this match. That means that that is my greatest common factor of 3x plus 5. And the other part will be then x squared minus 4. Now, we want to make sure that we don't just stop there because it's going to mess up your restrictions if you don't factor that difference of two squares. Some people will still write down the right restrictions. A lot of people are going to mess up. So when you factor this, another thing I notice people do is they totally disregard the other factor and it's gone. No, 3x plus 5 is still there. X squared minus 4 will factor into x plus 2. X minus 2, these conjugates right over there. So my numerator is 3x plus 5, and again in parentheses, x plus 2, and x minus 2. My denominator, well, it really was that anyway, right? So it's going to factor into those two things as well. X plus 2, x minus 2. Now, if you've done these problems using the way I ask you to do it, I have you write down the three letters F, R, S to remember what to do. Fully factor first. So this is really F, okay? Fully factor first. Fully. That's why we didn't leave it as x squared minus 4. We fully factored. So fully factor first. R. R is the restrictions. That comes before you simplify. Alarm, alarm, alarm. Reminder, reminder, reminder. Remember restrictions, and it comes from your denominator. Anything that's ever in a denominator will give you a restriction, and you do it before you simplify, okay? Before. If you wait till after, you're going to lose stuff. So how do I find my restrictions? You take anything that's in your denominator and you set it not equal to 0 because your denominator, each bubble, each factor can't be 0. 0 times anything 0. We can't divide by 0. The end. Play again in slow motion. Rewind, listen to what I said. So if I isolate x to figure out what x cannot be, as opposed to finding what x should be, we'll get x cannot equal -2. Same idea there. X minus 2 cannot equal 0. Of course, the order doesn't matter. Multiplication is commutative. Should be self-explanatory at this point, right? That right there is gone. X cannot equal 2. So these are my 2 restrictions. Even if a question is not asking you for restrictions, state them, okay? There we go. So fully factor first, we did that. Restrictions, we did that. Last step, simplify. X plus 2 as a whole and x plus 2 as a whole, cross out, simplify, reduce. Don't say cancel. You're better than that. Ooh, sorry, hidden camera. X minus 2 as a whole crosses out. You're not crossing out x's, 2's, x's, 2's. No. The whole factor, the whole parenthesis, okay? What's left now is 3x plus 5. There you have it. That is your simplified answer. Beautiful. I hope you love it. And I'm going to, as a bonus, because I love you so much, I'm going to show you how to do this with long division. You could click through to that, or if you are not so inclined to learn how to be fancy and smart, you can click through to the division problem that is next on the playlist, the x cubed minus 4x squared plus 3x plus 2. You want to just jump to that? Go nuts. If you feel good about this example and you are motivated to see the next thing, thumbs up, thumbs down. If you hate it, hate me, hate the video, hate the example, I don't care. Put a thumbs down. Doesn't hurt my feelings. Have a great day. Bye.